Um, so first, a quick note about my slides. Everything will be online, so don't worry too much if you cannot follow it. I will send you the link after it. So I have a few questions to begin the talk. Is anybody or do you use JavaScript? Do you write JavaScript? Oh, cool. So are you also using C++ or Rust? Oh, nice. Okay. And do you know how to use a computer? No? Oh, damn it. Okay. So, hi, I'm this guy. So, I'm one of the core maintainers of Babel. It's a JavaScript library. I don't know if you know it. The logo in the middle is TC9. It's the technical community behind JavaScript. So these are the guys making JavaScript, and I can try to help, which is pretty cool. You can also follow me on Twitter if you want to follow my work, or just have a quick chat there. It's fun. So first, I'd like to start with this quote. So the web is everywhere, right? You have access to the web on mobile. You have web views. You have everything. The web is everywhere. And WebAssembly aims to expand it to the rest of the world so that people using languages that aren't targeting the web will be able to do so in the future. So this is the main goal of WebAssembly. So you might be asking if there is an issue with JavaScript. And I can't really say yes, but there is. But the real issue is that you have some languages that aren't made for the web, that are targeting JavaScript because you have no choice. JavaScript has a monopoly in the browser, right? You don't have any other choice to run code in the browser. So they are targeting JavaScript. But JavaScript is super dynamic and completely untyped. So it's definitely not a good compilation target. And it was, never made for that purpose. And this is where WebAssembly aims to fix this issue. So we had some previous experiments, like ASM.js, which is the most known of them. The previous one was like very browser specific, and nobody wanted to support them. So you probably never heard of it. But WebAssembly is the first time everyone wants to join a common effort to be able to run native code in the browser. So it's very cool. So from a user standpoint, all you have to do is take your compiler of choice and just specify the target. WebAssembly, here is WebAssembly 32 bits, but you also have 64 bits if you need like more than 4 gigabytes of memory. It's just not as common yet, but it will be common. So once you have entered this command, it will generate a binary. This binary, you can directly load it into your browser, and there we go. You have executed, I don't know, C++ code or Rust code or whatever code in your browser directly. So it's really simple. There is another quote. I truly think that it will change the way we build and ship our applications. I will go through what that exactly means. So here is one application, one web application, where you have on the top JavaScript, and it will the red things are WebAssembly modules. So you have the JavaScript, which is loading a WebAssembly module written in C++, and which is loading also a Rust module, which is also written in Rust. Or you have Go, or you have C, and whatever. It's really up to you. This might not be the best architecture, but it's an example, right? So WebAssembly is safe and fast to execute. A quick side note that the compiler used in the native environment are emitting very optimized code. Like LLVM is known for this kind of stuff. So the code you are shipping to the clients via WebAssembly is really optimized. And it's not really the case in JavaScript. Because in JavaScript, the best we can do is minify our code or do simplest the optimization. There's just you can do really much with JavaScript at this point. One thing I really like is that it's says to be deterministic and easy to reason about. What that means is that when you look at a code, you can predict the output of your program. Which in JavaScript, if you look at a comparison or an addition, it has multiple side effects. So you cannot predict the output in most cases, yes, but you have a few edge cases, right? The thing I like the most about WebAssembly is that you will have native speed in browsers, right? And to be fair, it has some overhead due to bounds check. It's like when you call a JavaScript function in the WebAssembly code, it has to check the boundaries that you are not doing illegal things or stuff like that. But apart from that, you have native speed, and there's a bonus because once WebAssembly will have a JIT compiler, you will have even more than native speed, potentially. So it's really cool. And the engines are really focusing in optimizing the boundaries between JavaScript and WebAssembly. It has optimization, like you can directly call a JITed JavaScript function in your WebAssembly code, which means that you have like no overhead anymore. It's just native code, already JITed. It's really super fast. There is one major difference between JavaScript and WebAssembly, is that its format, the format is text in JavaScript. It's like a waste of bandwidth when you send it to the client. So what the major difference is that we will stop that and send binaries instead, which are really compact. And it had all these nice properties because it is easy to validate, to generate, and so on. One cool thing here is that it's streamable, which means that you can decode, compile, and instantiate the WebAssembly module while actually downloading it, which is not possible in JavaScript. So this is a major difference to me. A quick note about the browser support. So everything is green, apart from IE 11, obviously. But you can use it already, like, pretty everywhere. A common question people ask me is that, is WebAssembly going to kill JavaScript? And my answer is simple, no. But I can't predict the future. Maybe at some point it will, but currently it won't. The thing is that JavaScript is really simple. You don't have to worry about setting up or using a compiler. You don't have to worry about types, even though you should. You don't have to worry about binaries and handling binaries and this kind of stuff. It's really simple to get started with JavaScript. But languages that target JavaScript to just target the web, or even languages that doesn't target the web, will be able to target WebAssembly and target the web. So it's really a major step further. Another question is, would we compile our JavaScript code to WebAssembly code? My answer is also simple. Like, please no, don't. But people do it. We'll do it anyway. The reason is, I already mentioned this, but JavaScript is super dynamic. It has no types, and it has a lot of checks because of the spec. So when you access an index on an array, you have like ton of checks because the engines need to make sure that your array is not actually an object and this kind of stuff. It's a waste of CPU, basically. There's one thing though, it's you can ship. There's one guy that took the JavaScript core, which is the engine behind, which is running on all the Apple devices, which ported it to WebAssembly, which means that on Safari, you can run JavaScript core on JavaScript core, which some people will use it. I don't know, but you can do it. it's people done it. So I'm glad there's most of the audience are JavaScript developers, so this is really appropriate. You have some like assembly script takes TypeScript and compile it to WebAssembly. And TypeScript is really similar to JavaScript. Or you have something called Walt, which is taking which is a new language actually, but it's similar to JavaScript, and it also compiles to WebAssembly. And in this case, so this is Fibonacci sequence. In this case, WebAssembly is more than twice as fast than JavaScript. And WebAssembly doesn't even have a JIT compiler, right? JavaScript in this case can take advantage of it. And it's twice as slow as WebAssembly. So it's really pretty impressive already. So I need to be honest because there's some incoming parts. There's some like missing features in WebAssembly because it's still like an MVP at the moment. And we are missing features to have broader adoption. I'll go through the missing features. Like one big is the garbage collection. You don't have a built-in garbage collection in WebAssembly. What that means that some languages ship their own. Some languages don't have a garbage collection, so it's better suited for them at the moment. For example, Golang, which is working on WebAssembly backend, will be shipping its own garbage collector because it has like specific optimization it can do it to it, and they doesn't want the built-in one, which is very generic. Yes.
Does that mean you can have multiple GCs in a mix?
Yes. But I can answer your question because it's a good question. There is one thing, I don't talk about this, but they have a notion of like it's called unmanaged closure, which is when you have two modules, you can take one function in the module and import it in a GC-able way. So you don't have to collect your references in the module you have the other module. You only collect the references in the one module. Currently, it's not optional because it's not there yet. But I mean, this will be there in the future. There are solutions to have multiple WebAssembly modules and not having multiple GC at the same time. Yeah. Yes. Yeah. So that's a good point. It will indeed increase the binary size because you have to chip your GC. But for the case of Go, I think it's worth because they have like their specific optimization to it, and I mean they have researched this thing, so I guess it's worth. So anyway, it's pretty hard because you have to track objects you can pass in JavaScript to WebAssembly and in WebAssembly to JavaScript. So the GC is actually a web platform GC. Exception handling. So you don't have any exception handling at the moment. Like if you have an error in your program, it just crashes. You are in a trap. But it's fine because it will be so you will go back to your JavaScript code and then you can handle the exception in JavaScript code. But this will be fixed in the future. Threads are also a good point because in JavaScript you had many attempts to threads. But the issue is that since JavaScript is a very accessible language, it's like giving people a foot gun because they don't know how to threads. It's maybe the first language they use. It's not feasible. But in WebAssembly, one thread, so we will have native threads, system threads, and the good concurrency primitives to it to handle this kind of stuff. So one major pain point at the moment is that you can't access the browser's API within your WebAssembly module. It sounds limiting, but actually it's not, because you can import any JavaScript function in your WebAssembly module. For example, if you want to log into the console, which you cannot do in your WebAssembly module, you need to import the JavaScript console function in your WebAssembly module. And then you can just call it with a call instruction and pass arguments and this kind of stuff. So it's really not a limitation, I think. There's one interesting property, I think, is that you can embed WebAssembly, the WebAssembly engine, in whatever program you like. And I don't know if you are building something which requires a WebAssembly module, or you want to execute arbitrary code that, I don't know, user gives you. You can use this because WebAssembly is pretty safe. You have like a small attack surface, I could say. So here you can import, and yeah, one of the cool things is that the embedder can provide its own API, like access to the console, to some IOs, and this kind of stuff. And here the WebAssembly module only exports its main function, which the embedder can call. So this is a side note, because in the browser you don't have this, obviously. So where is WebAssembly now? Well, it's best suited for non-garbage collected languages like Rust. It's probably the best language at the moment. You can do really CPU-intensive computation. Like, so some people say that WebAssembly is currently just a fancy calculator, and well, you will show the types later. But the thing is that you can, like, what I wrote is that you can call JavaScript at the rescue, which means that you can import any JavaScript function into your WebAssembly module. So you can do everything you can do in JavaScript. So I think it's not a limitation at the moment. Like, there are some game engines, Unity and Unreal Engine 4, and maybe some that I'm not aware of, that compiles to WebAssembly. Like the one on the right side is a native mobile application written in Objective-C, I think. And the guy just ported it to WebAssembly to be able to play his game in the browser. It's pretty cool. On the right, you have the links here, by the way. On the right side, you have a game which is exported to the web via WebAssembly. So it's just the Unity export, which uses WebAssembly under the hood. It's pretty cool, and they are actually super responsive and feel very fast. It's pretty impressive. Another example is that you may consume libraries that uses WebAssembly under the hood, and this is completely transparent to you. This is an example. It's called Long.js. It's a library which provides 64 bits arithmetic over 32 bits architecture, like JavaScript. And it uses WebAssembly under the hood when available. So a simple division, it's almost twice as fast as JavaScript. So it's really cool. You have a lot of languages that already targets or will be targeting WebAssembly. And you have even the whole .NET platform. So everything that runs on .NET will be able to run on WebAssembly. You also have brainfuck, because why not? One note about HawkCamel. So there is one guy working on the HawkCamel WebAssembly backend. We will have a demo at ReasonConf, which is in a few weeks. So I'm pretty excited about that. Yeah. Yes, good point. So actually, they had this link here where all the languages are. I think I have to cut some because of the space I have in the slides. But yeah, Go is one of them, definitely. Thanks. So I will go maybe a bit into WebAssembly's internals and how it works, really. So there's this sentence, which is, WebAssembly is an instruction set architecture for a stack-based virtual machine. So I use this for meditation because it's really cool to say that. But it's really simple. I will go into what this means. So first, an instruction set architecture, or ISA for short, is like x86. It just defines a set of instructions which defines an architecture. It's really simple as that. And a stack-based virtual machine, I will go to some example, but the equivalent we are used to use is this register-based machines, like assembly, you just manipulate register, right? So here are 3 example instructions, and it's pretty easy to understand because they have usually the result type at the beginning. Like the first one creates a i32 bits integer based on the n input you give. The second one is just an addition between 2 32 bits numbers, and it returns a new 32-bit number, and so on. And you have the call instruction to call a function. And now the stack. Does anyone, please raise your hand if you use the stack, if you know what the stack is. Okay, cool, I will explain it. So it's maybe the simplest data structure ever because it has only 2 methods, which is pop and push, which are constant and time complexity. And so I have an example I can show you later. You have some languages that are only stack-based, like Thorf. Is anybody using Thorf? No? Okay, it's fine. I can't use it. Anyway, so in WebAssembly, each time you enter a new function, it has some kind of implicit stack. Like if you just enter the function, it's empty, and when you have some instruction, you manipulate the stack, and when you leave this function, the stack is done, goes away. But you have the result. And actually, you have many, I would say, low-level stuff that uses a stack under the hood. Like the JVM uses a lot of stacks for its internal data structure. Or you have even the call stack, which everybody knows. It's just a pile of frames, right? It's really simple. So I have an example. Sorry for bringing Fibonacci up again, but everybody is familiar to Fibonacci, I guess. Cool. I don't have to explain it. So here's my implementation of a stack in JavaScript. And I'm a bit cheating because the array has the methods I use, pop and push, so it's fine to use it. But you might have, I don't know, more complicated implementation, right? So here's my implementation of the Fibonacci sequence, which is the first 2 lines. I need the initial values. Then line 5 and 9, I'm going to take off of the stack the 2 last elements. I'm going to push them again because I need them also. And then on the line 12, I'm going to sum the 2 last elements I get and push it on the stack. And you can go so on until 1 is not anymore. And this is the Fibonacci sequence, right? It's really simple. I will talk a bit about JavaScript API. So you have one WebAssembly global object in JavaScript, where you have WebAssembly.module, which is just the representation of a WebAssembly module. You have WebAssembly.instance, which is the instantiated WebAssembly module with its live memory, I guess, with its state. Then you have the memory of a WebAssembly program, which you can manipulate in JavaScript. You have a table as well. You can register a function and do indirect call in your WebAssembly module. And the memory and table are exportable and importable in your WebAssembly module, which means that you can create, I don't know, maybe a memory object filling some memory in it, I don't know, numbers, string, whatever, and then pass it to WebAssembly module, and then the WebAssembly module can use it. And the reverse is true, so you can create a memory in your WebAssembly module and export it to JavaScript. So it's really cool. There are quite a few representations of a WebAssembly module. It's maybe confusing. I'll go through them. So here's the binary one. So it's a hex dump because it's just binary. It's just a sequence of bytes. It's maybe not important, but there's something cool. On the 4 first bytes, you have the file type. So it's OASM. And on the 4 next bytes, you have the version, which is O1. Just a cool trick. You have the WebAssembly text format, which is a direct translation of the WebAssembly binary format. It's like you disassembly it. It's maybe a bit hard to understand and to use because everything you do is based on the index. Like I want to export the add2 function, and I refer to the function number 0, which is this one. So the index are based on the function declaration. And it's called what? Because they couldn't pick the abbreviation of what the fuck. Because there will be a bad idea, I think. But we have a WebAssembly script format, which is a more high-level WebAssembly text format. So you have like nested instructions. You have like names. So you can export a function given its name. So it's really simple to use. And you can actually write this by hand. It's even easier than writing assembly code by hand. I showed you this because source maps aren't a thing yet, which means that you have to, when you have an error and you have to debug, you probably have to look at this and figure out what is wrong. But don't worry, source maps are coming, so you can look at the original source, which is, I don't know, the language you use, like Rust, C++. You can directly use it in your browser. So that's a good thing, and it's coming. So let's talk a bit about types. I love types. So WebAssembly has only 4 basic types at the moment. You have floats and floating points and integer, either in 32 bits and 64 bits. But you will have more types in the future. This, I don't know if I mentioned it, but WebAssembly is just MVP yet. It's the first version, it's the first version of the spec. It's not a test, it's more than a test, but it's an MVP. So anyway, things are coming fast. So you have a function which takes any number or type of arguments and eventually returns a new type, the result type. In the future, we will be able to return multiple return types. So that's pretty cool also. And you have a global type, which is either mutable or either constant. And it has type T, which is one of these. So there's also a type checker in the spec. It's quite complicated, I guess. It's another subject. I won't talk about this. But I have one paper of one of my colleagues, which is taking the basis and really go through the type checking thing. It's a really good thing. And you have a more formal one, which is going to the reduction of a module, and go check them out. It's definitely worth. One cool thing, which is not, you don't have this in regular stack-based languages like Forth. You have local variables into your function. So you have an API which is just go get the value or set the value, and the locals are gone once you exit the function. It's just like local memory, basically. It just simplifies the operation you could make on the stack. I mentioned this earlier. You also have globals, so either mutable or immutable. You can import only immutable from JavaScript, but this is also going to change. And you have the same API to get them and fetch them and set them and whatnot. So the main memory in your program is called a linear memory. Is everyone knows what a linear memory is? So this example is just a sequence of bytes. So I have an address and it just points to a byte. You can store it like this. And this is the character representation, which is actually decimal. And so you can use this in WebAssembly, like filling those cells, and then use it in JavaScript to get those cells back. Because I mentioned that in the types, you don't have a string. So you need to figure out a way to pass a string. And this is a good way to pass a string. This is the API to get access to the memory, so you have just store and load, and it's pretty common. One cool thing, so I can summarize this. The linear memory is not in the same address space than your code, or the execution stack, or the engine's internal stuff, which means that you don't have the hacks in C++ where you can just jump to locations, or you can buffer overflow and corrupt all the memory and this kind of stuff. You don't have it. So WebAssembly is really safe in this regard. The specification itself is pretty cool because it's written very well written in a formal manner. So everything is formally proved and sound and this kind of stuff. And one important thing though is the absence of independent behaviors, which means that everything that will happen in a program is defined, and that's how it works. Which sounds a bit weird because this is the spec, this is how it works. But in C++ or this kind of thing, you have like stuff that goes that you don't know what happens. So you don't have this. So how to get started? You have multiple resources online. You can just play around. You have the Mozilla docs, the Mozilla web docs, which are really useful with a lot of resources and a lot of how to get a hello world and this kind of stuff. So you should definitely check them out. I also personally have, not personally, but we have a project where I have a WASD and a WASM parser. You have an interpreter, you have an AST manipulation, you have a parser, you have code generation, this kind of stuff. So if you want to get your hands into WebAssembly real deep, you can just ask me and I can maybe help you to get started in this project. We also have a REPL, an online REPL, where you can play with the WebAssembly text format and play with it. And so I need to warn you because it's using our own interpreter, so we don't have all the features, but we are working on this. A quick note about JavaScript bundlers. So you are all using Webpack or Rollup. Cool. So I have a small example where imagine you have a C++ code, like a module, and the export is actually a macro which is defined in WebAssembly.h. It's just an external function. And there you have a console log, which is also defined in this. It's just a mapping to the console log JavaScript API that I showed you earlier. And then once you compile it and give this to Rollup or Webpack, you can use it like this. Just import it, get the test function which is exported here, and just call it. And it will log test into the console. Oh, hi, into the console. So it's really simple to use, and the bundlers are doing the linking thing behind the scenes and making sure your functions are there when you use them. It's really simple. An other example is taking advantage of the ES6 JavaScript modules here. So in your project, you can import the counter.js, which exports a number, which is here. And I don't know, you can do something with it. You can just return it. And here, in my JavaScript code, I can just load the module and call the get function, which is returning me this value. It's really simple, and it really aims to integrate well in the JavaScript ecosystem.
Question. Can you go back to the previous slide?
Yeah.
In C and C++, you cannot link binary if you don't have the implementation for that function, either in a shared library or static library or somewhere else. Does that mean that the WebAssembly SDK provides static implementation, or how does it work?
So I can show you the code on. I have it online, the underlying WebAssembly.h. But console.log is just an external function in the WebAssembly.h external. So there's no implementation. I mean, it's just external, and once you link this in the bundler, it will just provide the function.
Okay, but if the binary is optimized, the code will simply be optimized away if there is no implementation for it.
But not if it's external.
the linker is free to remove functions which are never used or not defined.
But I mean, here you're using it. Yeah, I see your point, but I mean, in my tests, the function is declared as an external, so when you compile it or whatever, it will assume it goes somewhere through linking at some point. And since you use this, I don't think it will remove it. But I mean, so even if it does, we are working, like the WebAssembly group is working on LLVM, Clang tooling to avoid this kind of stuff and to make sure that you can use those kind of functions and that it really plays well.
Okay.
So that's it. There is my slides on this URL. You can go on it. Thanks.